Formation of nitric acid in the atmosphere. During lightning discharge, N2 from the atmosphere reacts with reacts with oxygen to form NO. This N2 reacts with oxygen in the atmosphere and forms NO. This NO then gets oxidized to form NO2. This NO plus O2 forms NO2. Then during rain, when there is rain, NO2 gets dissolved in water in the presence of oxygen. H2O dissolving in NO2 plus oxygen forms HNO3. This is how HNO3 is formed in the atmosphere. Laboratory preparation of HNO3. In laboratory preparation of HNO3, concentrated H2SO4 is used as it is a non-volatile acid. Salt of sodium nitrate is used and reacted with temperature less than 200 degrees Celsius. It forms NaHSO4. This is also known as sodium bisulfate and forms HNO3. If NaNO3 reacts with H2SO4 in the presence of temperature greater than 200 degrees Celsius, Na2SO4 is formed. This Na2SO4 is difficult to remove from the glass because it sticks to the surface. Temperature is less than 200 degrees Celsius because Na2SO4 sticks to the glass and it's sticky to remove. The glass apparatus can also crack due to high temperature. Large amounts of fuel is wasted and HNO3 decomposes at high temperature. The acid formed in the lab is yellow. It can be removed by passing carbon dioxide through the acid or adding water to the acid. Laboratory preparation at large scales is by Ostwald's process. Main reactions for Ostwald's process is ammonia reacts with oxygen in the presence of catalyst platinum at temperature 800 degrees Celsius to form NO and H2O. This NO then gets oxidized in the oxidizing chamber to form NO2 and temperature is 50 degrees Celsius. In the absorption tower, then NO2 is absorbed in oxygen and water, forming HNO3. Air is used in more ratio because air contains only 1/5 of oxygen, or oxygen is contained in the air only 1/5 of the total air that is used, and oxygen is used in all the three chambers: contract chamber, oxidizing chamber, and catalytic chamber, oxidizing chamber, contract chamber, etc. Quartz is also used because it is acid resistant, and when packed in layers, it helps in dissolving NO2 in water uniformly and is efficient. Chemical properties of HNO3. HNO3 is very unstable to heat and decomposes at room temperatures. It reacts with base to form salt and water. Simple reaction: acid plus base, salt plus water, and reacts with salts of carbonates and bicarbonates and sulfites and bisulfites to form CO2 and SO2. Also used as an oxidizing agent, oxidizes sulfur to nitrogen dioxide, oxidizes carbon to CO2. Action on metal. Reacts HNO3 very dilute HNO3 reacts with copper to form copper nitrate, water and nitric oxide. Then copper reacts with concentrated HNO3 to form copper nitrate, water and nitrogen dioxide. In dilute it was forming NO2 and here it's forming NO. In dilute it was forming NO and here it's forming NO2 with concentrated. 1 volume of concentrated HNO3 and 3 volume of concentrated HCl forms aqua regia. Aqua regia is a mixture which is used to dissolve metals that do not dissolve ordinarily at acids. Like platinum reacts with Cl to form PtCl4 and Au reacts with 3Cl to form AuCl3. Brown ring test. In a brown ring test, in a test tube, HNO3 is added and freshly prepared ferrous sulfate is added plus FeSO4 is added, and then we add sulfuric acid drop by drop to the sides. Due to these three mixtures, a brown ring appears there at the junction between HNO3 and H2SO4. The reaction for this test brown ring is ferrous sulfate plus sulfuric acid plus nitric acid. This forms Fe2SO4 whole thrice plus water plus nitric oxide, and this FeSO4 then reacts with nitric oxide to form FeSO4.NO. So this was all for the chapter nitric acid. You can take a screenshot if you want for more.